All right, so when we're looking at a classic question like this, where you're dealing with some kind of inclined plane, an object on it, you've got friction going on, we have a couple new equations I want to introduce to you. And the first two are, they're not actually super different from what you should be sort of familiar with x and y components and finding the x and y component. But basically, we have a special equation we call force parallel. This symbol here means parallel. This symbol here is for force perpendicular. And you take the force of gravity, then you multiply it by the sine of theta or the cosine of theta. And it's important to understand what these symbols mean. So I'll show you that as we look at it here. So basically, when you're dealing with projectiles and you start thinking about x and y components, that's great. But really, you're just breaking down the vector into two dimensions. And instead of using x and y components when we deal with an inclined plane in gravity, you basically can work through all of the trying to solve the triangle using trig functions. But the reason why we just use this as a shortcut is because it just saves having to redraw and figure out all of the trig functions every time. And the important thing is theta is the angle off of the horizontal here. That's also this interior angle here, but that's not really relevant. I can prove that to you if you really need to see that. But the important thing is this theta, as shown in these equations right here, is this angle right here. What these equations do, it allows you to calculate this force that is parallel to the surface you're dealing with and a force that's perpendicular. Because what we find is when you have gravity pulling down on something, and it's on an incline, the incline pushes this way, and then you get another force that's pushing downhill. This is, of course, why things slide down hills or roll down hills or go down inclined planes if it's steep enough, if friction isn't big enough or something like that. So what we're looking at here is how does the force parallel and the force perpendicular, and that's what these equations tell us. Another thing that you're going to want to know, and we'll work some examples in another video, is, and this may or may not be helpful to you. If you're the kind of person that does well with equations, I highly recommend you writing these down. I'll move this up so you can see that one too. Basically what we're dealing with is on these, oftentimes you're trying to find the net force of what's going on here. And sometimes it's useful to think about the net force. This is just basically using Pythagorean theorem. If you have the two sides, the x and y component of a force, you can solve for the actual resulting force. Some of you may find this useful. If you don't, this is not something that I think works for everyone, but this is something that we can use at times. I'll show you how to work some of these specifically in a video, but I want to make sure that you get these two equations into your notes and that you know what each of these things stand for relative to a question that would look like this. Thank you. Best wishes.